All right, this is the very last section. You'll probably notice that we skipped 9.8. I don't know what 9.8 was, but we decided that it wasn't worth it. So 9.9 is basically review. I am pretty sure we have already done this stuff. We are adding and subtracting and multiplying polynomials, and it's basically just learning to use function notation. Trevin, are you awake? Yeah? Okay. So totally easy stuff today. We are, here we go. I'm going to turn the page here in a second. Okay, there it is. Here we go. Example 1. Express the result in standard form. Our final answer should be in standard form. What is standard form? Yeah, ax squared plus bx plus c. Getting basically all your ducks in a row. It's typically how we refer to standard form. We have f of x here. This is just fancy for y, but the reason we use f is to say, oh, look, I'm looking at two different things. I'm going to call one f and one g. And now I know when I say, look at the f function, you know which one we're talking about, huh? Okay, if they were both y, then I'd have to be like, okay, look at y equals x squared minus 3x minus 70, so that you'd know I was talking about that. Okay, so we use different letters like f and g, or p and q, or w and z, okay, to represent other functions, just so it's easier to see which one we're talking about. Okay. We have g of x is x minus 10. We want to find f plus g of x. This is how we read that, f plus g of x. What that really means is we're adding f and g together. We want to add them together. Our answer will be in terms of x, meaning we're going to have some terms. They're going to have x's in them. That's what that means, okay? So really, we want to add f and g together. This notation really means f of x plus g of x. That's all it means. Let's take our f function and add it to our g function. What can I replace f of x with? Yeah, x squared minus 3x minus 70. And then what can I replace g of x with? Yeah, because g of x is the same as x minus 10. So a big plus sign in the middle, and then we're going to have x minus 10. So all we're doing is substituting, nothing hard. What do we need to do after that? Combine like terms, which I stress is a better word than solve, because solving means you're getting x by itself, and we don't want to do that. We are just going to combine like terms. Does x squared have any friends? No. So 1x squared. We have a negative 3x and a positive x. What's that? Negative 2x. Very good. Remember, that's a 1, a positive 1x, and a negative 3. The negatives win by 2. All right, and then we have negative 70 and negative 10 makes negative 80. Excellent, ladies and gentlemen. That is in standard form. That's the answer. Combine like terms. No sweat. All right, so here, letter B, we have f minus g of x. That's how we'd say that, f minus g of x. And again, all that means is we're going to do f minus g. And our answer will be in terms of x. It's going to have x's in the answer. That's what it means, okay? So we need to do the f of x function minus the g of x function. What's the hard part about this? The negative. Negatives are always more challenging. Watch the subtraction. Write that down. T-R-A-C-T-I-O-N. Watch the subtraction. Addition is easy. Subtraction is always a problem. Always. What can I replace f of x with? Good. X squared minus 3x minus 70. Then we have a giant subtraction sign. And what can I replace g of x with? X minus 10. Now, is this correct or is this not quite correct? Yeah, we have to subtract the entire g function. We have to not only subtract the x, but we have to subtract that negative 10 as well. And so you can take care of it all in one step by distributing and then writing that down. But I'm going to do it like this in 2 steps. Now, we do need to distribute that negative. X squared minus 3x minus 70. What's negative times x?
Negative x.
What's negative times negative 10? Positive 10. And now we can combine like terms. X squared has no friends. We have a negative 3x and a negative 1x, which is negative 4x. And then we have a negative 70 and a positive 10, which is negative 60. And here is our answer in terms of x. And that is a literal statement. You guys have no idea how long it took me to figure out in terms of x, like what that meant. It's a literal statement. We math people are not like, it's not like some allegory thing in English, right? Or language arts. Like, there's nothing like that. I remember as a junior in high school, we were reading The Great Gatsby. And there's this chapter where the turtle's crossing the road. And I know, there's a turtle crosses the road in the middle of the Dust Bowl. And a car zooms by, whacks the turtle. The turtle like flies around, spins around upside down on a shell. And our teacher's like, what does it mean? And I was like, it's a turtle. He got hit by a car. And then this other kid who is like a genius pianist. You can like look him up. He's got 1 million YouTube followers. He says, it's like the meaning of life and the uncertainty that we have as we go about our day. It's just all uncertain. We never know what's going to happen next. And I'm like, what? Like, it's a damn turtle. Get over yourself. Like, so in math, we are totally literal. In terms of x means, how many terms do you see here? 3. Do you see an x? Yeah. Yep. So it's got some terms with x's. That's what that means. Okay. All right. Last letter here. This is the same stuff as above. I just wanted it on the same page here. What operation are we doing here? Multiplication. Yeah, this is just f times g. This is really just f of x times g of x. Would it also be acceptable to do g of x times f of x? Is that okay? Yeah, because does order matter? No, not on multiplication. Does it matter on addition? Not on addition. Does it matter on subtraction?
Yes.
Totally matters on subtraction. But we can change the order of these because, does anyone know the word?
Oh, I know it.
Starts with a C.
Commutative?
Commutative property. Commute.
Oh.
Good. Commutative. C-O-M-M-U-T-A-T-I-V. Commutative property. Yeah. Hey, there's one of those crazy words that you're like, why do we need to know that? Commutative property. The only reason I want to do that is because I want the little thing first. G of x is x minus 10. And f of x is x squared minus 3x minus 70. And I got to multiply these things together. All right. So big parentheses there. We got to multiply everything. There's lots of ways to do this. We could distribute. Or we could use a method. The box method. Do you remember that? You don't remember that?
Oh, yeah.
Yeah. We got x squared minus 3x minus 70 on top and x and a negative 10 on the side. And then we just fill in the spaces. This is my favorite method. What is x squared times x? X cubed. What is negative 3x times x?
Negative 3x squared.
Good. Negative 3x squared. What is negative 70 times x? We have x squared times negative 10. Negative 10x squared. I almost dropped something there. Negative 3x times negative 10. Positive 30x. Negative times negative is positive. Negative 70 times negative 10. Positive 700. And then all we have to do is what? Combine like terms. And the nice thing is they should all be pretty organized. And the really nice thing is that it'll catch a mistake if you notice what's going on there. Whoops, that's supposed to be x cubed. There we go. Here we have negative 3x squared and a negative 10x squared. What's that give us? Good. We have a 30x and a negative 70x, which gives us negative 40x's. And then the last thing is that positive 700. I love me the box method. You can actually divide polynomials that way too. Doing the reverse. If I give you the answer and one of the sides, you think you could figure out the top? Yeah? Reverse process there? Interesting. We do that in Algebra 2. All right, ladies and gentlemen, do you have any questions for me? Today is totally easy, which is great. You have a Delta Math assignment. You should be able to get that done lickety-split. And then if you didn't finish Monday's assignment, you can do that. I believe the review is also posted if you want to start the review for the test. Okay? Use your time wisely. 12 minutes